Good morning. Let's continue with our top interview questions on LeetCode. Last one in 2 pointers. Let's go. Threesome. That's loading very slow. Alright. Start the timer. Given an integer array, triplets such that different indices and the sum is 0. Okay, and the solution cannot contain duplets. Alright. Well, we have all done the famous two-sum problem. Numbers. Order doesn't matter. Okay. Three sums. 0. So first idea would be that we have a loop over one of the elements, and then the rest of it we do it as if we're doing two-sum. So we traverse the nums. First we have -1. So first round of the loop is -1, and then we are looking for two-sum in the rest of this with a sum of 1 so that it can all add up to 0. So for two-sum, we were able to do it in linear time at the best. So for two-sum, I think we were using a dictionary. Dictionary storing the value and its counterpart. Right, okay. So using a dictionary to do two-sum, linear time, and then we were gonna, so for this we will be taking 1 out, and then the rest of it we want to be looking for -1 as the two-sum target. That's what, oh my god, that's what I can think of so far. Then we also need to remove duplicates. Alright, let's code this. I'm trying to think how to avoid the situation where I'm taking one element, then essentially I want to do two-sum over these elements, but I do not want to create a new array. That's extra unnecessary operation. Okay, I guess we can just have that index and then skip. Okay. The result will be a list of lists, like this list of lists for each number. But we want the index. So this is the number, and the target would be minus that. Do we need the number? Let's have target for now. Actually not sure if that works. We'll see. So that's our target for the two sum. Now we want to write the two sum algorithm. Let's put it into another function. Self, we want this nums, so we don't need to name it. We want this list of integers, and we want that index to know where to skip. So we want to create a dictionary. Nums let's say this is the part we want to do two sum on. So for each number, what do we want to store in the dictionary as key and value? Oh, we also need a target, because it will not always be 0, it will actually be different. So target, let's say target is 2 for this part. Well, no, let's just use the real example. So for this one, the target of this two sum will be 1. So that's 1. So first we have 0. So do we check for duplicates here? What happens if the dictionary already has a key value of 1, and then we want to add? It should just be replaced. Okay, so so that's the key. What about value? Should we just write the number as value? Okay, let's have that for now. So this will be dict 1 minus 0. So dict 1 is 0, which means we're looking for the number 1 in the rest of this input. And then we go to 1. So then we're looking for 0. So we already put in the dictionary as value that we want to look for 1, and now we see that there is 1. If number in dict, that means we have found it. Then we can return. What do we want to return? We want to return, let's say, a list of the number and the last element that gave that key. Okay, so that's the idea, and now we want to also skip so in this case we are skipping index 0. So we need to skip that and not check that. All right. We need to use this because we need that index. If I equals to skip, then we just continue. If we cannot find anything, what should we return? Just empty list. Not sure if I can return it like this as an empty list, or I should put it in as null. Let's try this. Okay, toSum. So that's the target. We want to run toSum. What we're skipping is current index. So if toSum is returning something, that means we have found a solution. If it's returning null, then we don't have any solution. Can we just return null instead? Actually not sure if we can do things like this. Python. I'm still new to Python index, so syntax aware we'll learn. Python check is not null. It says that I should be checking is not none. Okay. Turn none. Let's try that. If this result is not none, that means we have found one result. And let's append current number, the result. Okay. Otherwise, we just continue. So after all of this, we want to make sure there are no duplicates. Okay, okay. So in order to check duplicates, I think we will need to first sort all these results so they're, because otherwise they will not be able to check duplicates if it's -2, -1, and -1, -1, 2. That will not be considered as duplicates. So can we sort this? We are hoping that it could sort the values inside of each list as well. Append. What if we sort it when we are appending it? And then we just remove duplicates. Using set. Method 1, method 2. Okay. Using set. Okay. List set. So if we use set, what would that return? Python set function. We are returning a list from that set function. Okay, let's try this. Pretty sure this is not gonna work right away. So let's see. ToSum is not defined. Why would that be? Python function is not defined. I mean, it can't be that is the order issue. I don't think that's the problem. Okay. Why is it not defined? ToSum self. Is it because it doesn't need to oh no, I'm stuck. I don't know how to fix this. Okay, I don't know how to fix that, so for now let's move this into this, and then I will figure out. We will refactor later. Unfortunately. Okay. Dictionary. Okay. Oh. Number. List has no attribute set. List set. Oh, okay, like this. Okay, so at least the code is working, but we're not getting the correct input. We're not getting any input. Let's see. Let's see if we are getting any result there. If number is in dictionary. Print. 1, 1, 0. Okay, so this is not correct. 1. So first round, first number is -1, target is 1. Okay, so this part is correct. So target is 1. Now we go in here. Number is the first one -1. It's where we should skip. Next one is 0. Zero is not in the dictionary, so we wanna add target 1 minus 0. Predict 1 equals 0. Oh, I see. This is not the one that we are skipping. Wait. No, this is J. Okay, now we have our results. That's the one we skipped, so that's one in the outer loop. This is what we found in the inner loop. Now, why is it that we are not getting any output? Okay, result is not none. If result is not none, appended none. Oh, why is that? What do we have here? The number we skipped and the result. Oh, because we use the sort function, the sort function is gonna return none. I see. let's see. What do we want to append in here? Pair. Triplet. Triplet is this. Triplet sort. And oh. And then append triplet. Let's see if that fixed the problem. Okay, so this is working. Although this part was not sorted. Why is that? This is not sorted either. So this did not get sorted. Append. Oh no. Triplet. Okay. Okay, now it is sorted as we want. Okay, now we just need to fix the last part of removing duplicates. Unhashable type list. Let me see what this is. Oh, you cannot use that in the set function. Oh, I see. It is not able to use the set function on this result because this is a list of lists, not just a simple list. Interesting. So we need to remove duplicates from a list of lists. Okay, I'm seeing this solution. Let's try that. We have a list of lists in Python. Import itertools, sort list of k for each k in itertools group by k. Okay. All right, let's try this. Okay, so we have our result list. Import itertools. So result. Do we need to sort that first? Oh, no. Not sure why we need to sort it first. Say list of result for group by assuming this could be just be k. K is not found. Case 1. It was able to remove some duplicates, but not all of them. Interesting. I mean, it can't be that it's missing the sort function. That'll be very surprising. It is because it's missing the sort function. But why? Why would that be? Okay, let's try this first. Okay, I passed a third of the test cases. That's at least promising. My output is this. Expected. It doesn't return all the output. Why is that? -3, 4, -1. Okay, so what are we missing? -4, 1, 3. -4, 1, 3. We have this. Why isn't this one returned? Oh, I see. Okay. Result. Okay. So this part is currently only returning the first encountered solution. Or okay, so we're not storing all the solutions here. We're only storing one of them. So first it will run into 1, and then we'll continue, and then the second one will replace the first one, and so on. So this will only give us the last solution that we are seeing in this little loop. So we actually need to save all of them. We make that into a list. We need to append this result. Well, okay, since now we're not using this separate function, we can actually just do this part right away. Okay, so now we found one result. We don't need that. We can just result append okay, so there we found one. Let's see, triplet is nums I still, and then we have current number and last number. Okay, so that's our triplet. We want to sort that and result append triplet. So So we don't need this anymore. And then we put that. If it's not in the dictionary, we put that in. Okay. Let's try this. Oh my god, it's been 40 minutes. Oh. I'm gonna eat breakfast after this. Oh no, it's running very slow, so it's not gonna. Memory limit exceeded. Oh, so all test cases passed, but memory limit exceeded. This is the first time I've seen this. Usually you just run into time limit exceeded, but memory limit exceeded. Interesting. To remove duplicates from list of lists. That's just a little note. Okay. Memory limit exceeded. We are using this result list of lists. We have a dictionary. That shouldn't be the problem. Triplet. We are sorting that. We append the triplet. Actually, I don't actually know why this would give memory limit exceeded. What is using up all the memory? Oh no. Okay, let's see. Can I save memory? Is there another way to not have duplicates? Instead of having all the results stored and then sort them and group by this, instead of this, could we process the duplicates some other way? Okay, so one thing would be that if we have already checked for -1, we actually don't need to check this again because that would just be unnecessary operation. I wonder if that will save memory though. I guess it will save a lot of duplicate solutions. Okay, let's add that logic in here. I don't want to add an extra dictionary just to track if this has already been checked. I don't have any better idea at the moment, because we already sorted them here, so it wouldn't look exactly the same. Okay, let's just try that. Checked a dictionary for already checked elements. So for nums I, so that's already checked. Checked nums I. Oh, we don't actually need this value, we just need the key. If nums I in checked, if nums I is already checked, we can just continue. Okay. Oh, okay. Alright, so it's accepted, but it's very slow. So I assume this is definitely not the optimal solution. Okay. Okay. It's just running one more time, just to be sure. Okay. Equally slow, equally bad. Oh. Okay, let's do the time and space complexity, and then we will look at top solutions and see the better solutions. All right. Time. Let's see. So this for loop is already gonna add a linear layer to whatever that's inside. So inside, we're hoping that this will be linear. This is basically the two sum. Okay, so that will be constant. We're checking value in a dictionary, that's constant. This is constant. So we use a dictionary here. We are checking this part. We have a number if we skip, and then for the rest of it, if it's already in the dictionary, we will form this triplet. We will sort that triplet so we can Okay, so even though this is linear, but the sorting is actually an log n, so that's not linear anymore. Result append. I'm wondering if I don't need to sort it there. Wrong answer. Yes, we still need to sort it. Okay, so sort, that's n log n. So now this is no longer linear, this is n log n. Okay, and then this add another layer of n. So this right now is, this entire for loop is right now n squared log n. Sort on the result is n log n. this part, okay, group by, group by should be linear. But we wanna check all the elements in each list in this list of result. Okay, we actually need to look up what this does exactly. So this whole algorithm right now is in squared log n. So it's not fast enough. And space, we are looking at it's mostly that result list that will take up space. This will be just a linear space, and this would be also linear space. Okay. So space would just be the result in a list that's taking the space. No extra. Okay. All right. Let's have a look at top solutions. N squared. Oh, wait a second. Oh, I just forgot this is supposed to be a 2 pointers problem. And I'm not even using 2 pointers. Well, I guess I'm using I and J. I guess, but 2 pointers. Let me think for 1 sec. 2 pointers. So I'm thinking, would it be a solution if we first sort the input so it's ascending, and then we have 2 pointers going from left and right, trying to so if we had, okay, so we sorted this, so we have -4, -1, -1, 0, 1, 2. Is there any way we can use 2 pointers on this? From left and right side, we are looking for a sum of 0. Oh, okay, wait. So the time complexity is actually not n squared log n, because it's only n squared, because this little sort here, it's only gonna sort on 3 elements. So that n would just be a constant 3 for this little sorting here. So that's gonna be constant. So this is actually n squared. So that's good. Okay. So I'm thinking how we can save more operations. For instance, we had -4, and then for the rest of this we need 4. If we check that this is only 3, then we know that the rest of it wouldn't make up 4, so we don't even need to check all the other ones. But if we had -1, we need 1. Then we still have to check all of them. Not sure how much that's gonna make a difference. Alright. Okay. Jump over the number which has been scanned. Okay, so the only jump I'm doing is this. If we have already checked that number, we continue. If 3 numbers found a solution, we can satisfy ignore all duplicates. Jump over the number which has been scanned, no matter it's part of some solution or not. It's not very clear what this means, been scanned. Okay. Target front back. Okay, it's using 2 pointers front and back. The sum. Target. Okay. So we are in a for loop. We have this current target here, like that. Front and back. Yeah, instead of using dictionary, we're using front and back. Pointers, yes. The sum. Okay. If we found it, we have this triplet. Push back. I guess that's append. Okay. Well, front. Okay. Number front equals triplet 1. Processing duplicates of number 2. Rolling the front pointer to the next different number forward. Oh wait, what if number of front is equal to triplet number 1? Okay, so this num of friend is where we ended up when we had found a solution. If that is equal to the second number in the triplet, oh, okay. Oh, I see now. So it starts with same as this, and then you just want to move the pointer forward as long as this is still the same number. To the next different number. And the same thing with the back. Okay, so essentially it's doing what this is doing. If we are having another of the same element, we don't want to check that all over again. So that's actually what I'm doing here. I wonder if they have sorted this input. I think it's sorted, otherwise it wouldn't make sense to scan like that. Okay, so that's sorted. Maybe that will improve the time because it's sorted first, then it simply needs to jump over. Well, this is jumping over as well, and it doesn't take any time either. Okay, processing duplicates of number 1. Oh, I see. I see. Okay. Okay, so using this as an example, first it's sorted. Alright, it's sorted. And now, let's say we are looking for target 4. So we're looking for target 4, we have this front and back pointer. And well, in this case, we do not find a pair that gives us that target. So we will actually not go in here. It will just run through it and then out. And then we're at this element, which gives us target 1. So, oh, look at that. So we're here, I is 1, target is 1, front is 2. We will not even consider this -4. We would only go over the front and back in that portion because why is that? I need to think. Only looking for 1. Actually, I can't think of the reason. why is it that we do not need to check this anymore when we are standing here? So that should explain this part. I will need to find the answer for that. Okay. Unfortunately, I can't think of the explanation. Okay, so front starts from this. Okay. And now, when it does find a triplet, that's when it starts doing this. If we had duplicates inside here, it would have hopped over. So we don't have to do that again. Okay. Okay, next round, same element, so we don't have to look all over again, we just skip like I'm doing here. So the biggest difference here is that once we have checked -4, we no longer even check -4 in the rest of the operations. Yes, that makes a huge difference to the time. But I still want an explanation of why that is justified. Jump over the number which has been scanned, no matter it is part of some solution or not. So I need an explanation for that, I guess. Jump over this which has been scanned, no matter if it's part of some solution or not. Let's see if anyone has provided some explanation. No explanation. What if we had -3 and 4? Okay, let's see. So when we are here, we need all the pairs that give us 1. So in this case, we have -3 plus 4 that gives us 1. But we have already checked that when we were checking -3. So when we're checking -3, we have already checked this combination. So that must be why we don't need to check backwards anymore, because that would have already been checked. So we can safely just look at whatever that's in front of us instead. Okay, I think that's the solution. That's the explanation for that part. Okay, so now I understand this fully. That's good. Okay. N squared, quadratic time. Okay. So this is kind of a long video. I think we will end it here. I will implement that solution just out of my head later, so I can practice that and see if it's gonna be more effective. So I'm not gonna do that now, it's gonna be too long a video. Let me know if you have any questions, and I will see you in the next problem tomorrow.